Welcome to another episode of the History Fuzz podcast. I'm joined by two guests in this episode, and we're going to be looking at some of the archaeoastronomical properties of Central Europe. Joining me today, I've got Walter Payne. Walter, I'll put it over to you to give us a quick bio.
You bet. Hey, Ash, thanks for inviting me on this. Going to be an interesting topic. It seems like I thumbed through all the slides. It's very interesting. Anyway, about me, I work for the United States Department of Defense. I'm an intelligence specialist. My background is remote sensing, satellite imagery. And as you know, Ashley, I love coming out to Colombia and mapping all these wonderful sites you discover. I don't know if you discover them or I don't know if people tell you about them, but regardless, these are some amazing sites you've had me come out to Colombia and map for you. What else can I say? I think that's about it. Is that good?
Walter, I think that's a fantastic. What I'll do is I'm going to use this as an opportunity to tell the listeners that if they want to come with you to Colombia, they can go to historyfuzz.com, and we're already putting our team together for February next year. So, moving on from Walter and I'd like to introduce Klaus Clausen. Klaus, could you tell the audience a little bit about yourself, and when you're ready, we can get right into your presentation.
Yes, my background is I'm an educated astrophysicist with special interest in megalithic monuments. The astronomical definition of equinox, and that the atmosphere, the refraction in the atmosphere, change the rising and setting times of the sun and also the moon, which can be a little bit confusing. And so it means that we also have to discuss when are day and night almost the same lengths. This will not happen anytime, except if there was no atmosphere on Earth. Then we could say there was what you call a real equinox, where day equals the night. But that's not what is happening in reality. Then I will talk a little about the refraction, and finally a little about the algorithm developed by the Friedrich Gauss in 1800. He called it computus. And finally, at the end, I will explain how the megalithic equinox works.
Before I scroll onto your first page, for the audience, I'll ask the question. Could you explain on the most basic level what refraction is? What are we about to dive into here?
Yes, the refraction in the atmosphere means that different wavelengths of light is refracted in different ways. The blue light is reflected on the sky. That's why the sky is blue. And red light is not affected so much by the refraction except at the horizon. So red light comes through the atmosphere, and that's why the sun is red when it goes down.
Are you saying that refracted light distorts the accuracy of the observation of a planet on the horizon? Is that what you're saying? A difference?
It changes the setting times and rising times, both for sun and the moon. So it means that the sun, for example, you see the sun before it actually rises, maybe a couple of minutes. And also you see the sun after it actually sets, and also to the moon. This effect is most pronounced at the horizon. The moon can change its rising and setting position at the horizon about 2 degrees.
2 degrees.
Then you have to yes. Yeah, the refraction, not the reflection, the refraction.
No, I get that. Why I'm trying to get to the bottom of this, Klaus, before we begin is because archaeoastronomers build in bands of error or degrees of inaccuracy in their research. But you would normally build in half a degree for heat of the terrain, for mist in the air, but you're saying a whole 2 degrees of inaccuracy visually by refraction.
Yeah, it's most pronounced for the moon towards rising at the south. It's called the horizontal refraction. It's built in my computer programs to correct for that.
What I'm struggling with is if I was in Neolithic times and I had built a temple complex or 3 standing stones pointing at where the sun sets on, say, the summer solstice, I could come along there one morning and that alignment's 2 degrees off just because of refraction. Is that right?
Yeah, it only goes for the moon. This is not so pronounced for the sun. Okay, maybe I should say that also another effect called parallaxes of the moon and sun. And for the moon, parallaxes changes also the position at the horizon. For sun, the parallaxes is only less than 1 degree. It's not very pronounced. But for the moon, this is for the moon that the horizontal parallaxes is about 2 degrees. I think the refraction is about 1 degree. So you have to combine these 2 effects.
2 degrees could represent 4 days. Yeah?
Yes.
As in the moon travels along, that could represent 4 days of time. So there could be great inaccuracy in determining any given date. But I think that now brings us into your presentation, right? That's what your work is.
Yeah, but as archaeoastronomy is not precise.
No.
It's no. So you have to think about that. What it did in Neolithic times, it was only almost the direction they pinpointed, and you have to take that into account when you try to make any models.
Okay, super. So would you like me to zoom on to the first page of your presentation, Klaus?
Yes, please. At the church meeting in Nicaea, year 225 AD, it was decided that the vernal equinox is always the 21st of March. And that's not right. It changes with 1 or 2 days plus minus during the centuries. But then it was easier to say when it was vernal equinox, simply because they have determined at the date the 21st of March. So when we got the calendar, first the Julian calendar and since Gregorian calendar, it was a problem because then the vernal equinox could not get on the right date. Okay, and also it was decided that Easter Sunday is the Sunday after the first full moon after the vernal equinox. But then in September 19th of 1582, Philip II, the ruler of Spain and Portugal and some part of Italy, he decided to change from Julian to Gregorian calendar. And this adjustment aimed to bring the astronomical determined vernal equinox closer to March the 21. But the problem is the full moon time is only a time. It's not a whole day where it's full moon. It's a special moment, and maybe you cannot observe when the moon was full before 12 o'clock in the night or after 12 o'clock. So a lot of discussion about that. That's much more in this history have been very confusing. But then Gauss developed the algorithm Computus in the year 1800, which give the possibility to predict the placement of Sunday Easter without astronomical observation. And it's a very complicated calculation. So after Gauss' development of computers, nobody has to go and see if the moon is full or it's vernal equinox, because it's built in this algorithm. But the algorithm make mistakes sometimes. It places Easter on the wrong date. So this algorithm had been adjusted I think a couple of times to make it more precise, but it will never be precise. I think that's, but we'll go back to Gauss' algorithm. It's still the algorithm is used by the church. And I think, I would like to myself, it's much more easier as the Danish astronomer Ole Rømer. He tried to change that Easter must always been in the beginning of April, and no calculations. It could be the first Sunday after 1st of April. But nobody listened to Ole Rømer. So that's the problem.
Klaus, let me ask you a question on this. Listen to what you've said. Is this all about an effort to bring the holy day, the perceived holy day of the resurrection, Easter Sunday, into alignment with the actual physical observable event of the full moon after the vernal equinox? This is economics, isn't it, Klaus? Because what you're trying to do, you can't have Easter on a Monday. Easter Monday, it's Easter Sunday, people spend money. Here in Catholic South America, Easter Sunday is one of the biggest economically rich days of the South America. Everybody goes out and drinks and spends money and has food and buys gifts. So do you think this is to control economics, or a genuine move to control the synchronization of Easter with the equinox?
I don't know, actually. I think which affected me was that how can Jesus resurrect on different dates? It's not possible.
Anything's possible for Jesus.
Yeah, he was.
I correct you.
I don't believe that. He was born Christmas. We have a date there, 24th of December or 5th of December. And suddenly when he dies, it's on different dates. I don't understand that. That's what affected me. And then I tried to understand how do we do that. So it's a mixture. It's a mixture of old rituals concerning the full moon, and a ritual concerning the sun during winter, the winter solstice. But the moon and the sun do not follow the same cycles, and they have been mixed in a way which is not rational or logical, I think. So I don't know anything about if there is economical aspect or a religious aspect. I have a house, or me and my wife have a house on Crete in Greece. They have Easter on another time that we do in Denmark. But in Crete, it's a big holiday where people eat and drink and so on. Also, we do that in Denmark, but on another time in Greece. And once the Pope, he said that the former Pope Franz, he didn't understand why his Jesus could resurrect at different times in different countries. So it's not based on logic. So I don't know. That's why my question is, how could we do it another way?
Yeah.
The placement of Easter. You have Christmas more or less the same date in many countries, or either the 24th of December or the 25th of December.
I think it's widely accepted that Christmas itself, or that date was chosen because it represented the winter solstice. The 21st of December is the solstice. You have 3 days standstill. And on the 24th, 25th, the light returns. I can understand how that reflects the archetype of Jesus, the arrival or the return of light. And of course, when the Romans put this in place, they overlaid the Saturnalia festival on the 21st of December, which was the largest festival in the Roman world. But Easter does remain a mystery. So I think there's logic behind the 21st of December, 24th being Christmas. But yeah, I think there's several lines of logic in the determination of Easter. It's not that it's without logic, but there's so many lines of logic, all claiming something different. Do you think that's right?
Yeah. Yes, because in ancient times, they could not measure exactly when the sun turns at the horizon. So they waited a couple of days and they say, now it's now. And then that's why Christmas is a couple of days after the winter solstice, I think. But that's a very old tradition. So, I think the church, when the Christianity came to Denmark, it was easy for the church to choose that the Christmas time was the same time as the people used to celebrate Christmas.
Yeah, I'm preceding, going back from Jesus, Horus of Egypt, Odin of Norway, Brahma, Buddha, Krishna, they were all associated with the winter solstice. Their festivals were on the 21st. So Jesus being another leader, a religious leader, being associated with the 21st of December isn't a surprise. But let's move on to your next slide, shall we? Will we move on beyond the background?
Yes, please.
Here we go. The spring and autumn equinoxes.
Yes, I have noticed the time when it was spring and autumn equinox. And there's no day where day and night equals each other. It's maybe a couple of days before the vernal equinox is a day and night is night is more or less equal, and also at the autumn equinox. So then we have to go back to the astronomical definition of equinox. It's when the sun is at the intersection of the ecliptic plane and the equator plane. And the point of intersection is the height of the sun above equator is 0. That's easy to measure today. But at the point of then ecliptic is apparent orbit sun is the orbit the sun is following on the sky. I think which is caused by Earth's rotation and rotation around the sun. So it's Earth's own rotation and rotation around the sun. So where is the Earth rotation axis have a slope of about 20.5 degrees. this orbit, you can of course measure the height above the horizon of the sun when it's the equinox, but the setting points and the rising points of the sun and also the moon is reflected by the parallaxes and the refraction in the atmosphere. So actually, when it's the vernal equinox, the sun is rising at 2 or 3 days before the astronomical equinox, where day and night is almost the same length, but you will never find a day where the day and night is at the same length. And it same goes for the autumn. So we don't have in praxis a real equinox. For the moment, it's the 21st of the 20th of March, and not the 21st of March as the church has declaimed or decided to be, and that makes the things confusing, as you will see later.
The 21st of March and the 21st of September are regarded as the equinoxes just now. But what you're saying is that even on those dates, or if it's the 20th, there's never actually a day where there's 12 hours of light and 12 hours of darkness. Are you saying it's always 12 hours and 10 minutes of light and 11 hours 50 of darkness? Is that what you're saying?
Yeah, but it's more or less, it's 12 hours and 1 minute of light and 11 hours and 59 minutes dark. So you can continue to the next slide, please.
Wonderful. Here we go, Klaus.
You see the vernal equinox, also called the first point of Aries, is the intersection between ecliptic and the celestial equator, which also are parallel to Earth equator. So it's defined as a geometrical point and astronomically determined time. That's a good definition. That's not about how it works when you see it through the atmosphere. But this is not really a problem, I think. The problem is that the church choose to choose the date, the 21st of March, as the vernal equinox. It's time. If you please we can show the next slide. Then we have the astronomical determined vernal equinoxes, and you see since 2008 until 2025, you only have on 2011 the 21st, the date, the 21st of March, as the vernal equinox. Otherwise, it's the 20th of March. And the same goes for September equinox, astronomical determined. So it means that when we use the old thumb rule that Easter Sunday must be the first Sunday after full moon, after the vernal equinox, or the 21st of March. This is an old thumb rule, but the thumb rule goes wrong many times, as we will see. So you can please continue to the next slide.
I have a question on this table, and it's this. If it's 2 days later for the equinox, would that not mean it's 2 days later for the solstice as well, which means we've got that wrong as well?
No, I'm not sure about that. Excuse me. I have not investigated that enough to know what could be wrong there. But
Yeah,
I
sure.
think that maybe normally we said that at the winter solstice and at summer solstice, you have the longest day and the shortest night, or the short, yes. And during the winter time, the shortest day and the longest night. But I'm not sure that it will be the same date as is determined astronomically. But it's a more complicated discussion, because it's about that the day at the at the solstice, it is about less than 1 second different. So we cannot see if the solstice is the 21st or the 22nd.
Yeah, sure.
And I tried to ask some people who has good computer programs. They could not answer me. So I have a good idea. Maybe the difference between the shortest day and the day after could be 100,000 parts of a second. It's more complicated. I've been talking with NASA about it, and they could not give me any answer.
Walter, have you ever worked with NASA?
Actually, I had an internship with NASA doing remote sensing of all things. No surprise there. But my comment thus far on all this is, it keeps in my mind. It keeps going back to time as a convention that we had to create. To keep track of things, to keep Ashley on time for these meetings, to keep everybody, in order. To kind of assign some kind of order to seemingly what would be chaos if we didn't know when to start something or when to end anything, for that matter. And I'm not saying that it's right or wrong. It is what it is. And what I find interesting is the numbers you have on this site, the astronomical equinoxes. I just didn't even think about that the difference would be so much. Those time differences would be so great. So that was kind of interesting there. But
that's it.
Yeah, I
like.
Go ahead.
Mm-hmm. No, please, Walter, finish.
I have to keep changing AirPods because my batteries are dying. Anyway, but yeah, it's and I find it interesting, the whole concept of Easter and Christmas is. I like what you were saying about when Christmas was, kind of celebrating the new light, and maybe the same is true for Easter. Maybe farmers knew when they had to plant, although I think that is not exactly on that day. It's more of an environmental thing, vice a celestial object thing. And maybe that is just when the church or whoever decided, hey, we got to have a day for Easter. We got to have the day for the rising, for the coming back and everything. And maybe this was the best time to do it. I don't know. Just a thought.
So my conclusion about the equinox is that there is not a correct equinox, or if we should call it that, equinox. It's some days before and after equinox. The vernal equinox, few days before and few days after the astronomical autumnal equinox. But it can vary up to 3 days. So if we should do a real natural definition, where the sun rises in the spring the sun rises in the spring in the direction of about 93 degrees, also in autumn. And funny enough, I have a long barrow here close to me in the forest, which have exactly this direction.
Oh yeah,
but that's it's the Megalithic monument is only a line towards the rising point of the sun. Is because of the natural definition. It was the same direction for 5,000 years ago, maybe one degree plus minus. I don't know, but it works. It's still working.
Today we celebrate a day, Easter.
But it's known that in South America, the solstice festivals, for example, lasted for about a week before the solstice and a week after the solstice. And so too at Easter, I would imagine, celebrated days before and days after.
This could be an example of that, if with my long burrow in the forest. So they celebrated the vernal equinox 2 or 3 days before it's actually happened.
On the last point you made, would you agree or disagree that the idea of the sunrise on the equinox itself can never be accurate, because surely that actual moment where the sun crosses the ecliptic, that could happen at like 2:31 a.m. before the sun rises, or 11:29 the night before. How would those megalithic people ever know the actual, because it's a mathematical calculation, isn't it? Actual equinox.
Yes. So they have to look towards the rising point of the sun. We were talking about in the beginning, the light is deflected in the atmosphere. An effect is that the disk of the sun rises above the horizon before it actually rises. And then it looks more flattened in the bottom when it rises, because the bottom is raised more than the top of the sun. That's why you see on the 2 pictures that the sun at the bottom is more flattened than the top.
Let me ask you, on that right-hand picture, are you saying on that right-hand picture that the sun, with the boat, the ship there, that sun is still actually beneath the horizon at the bottom?
Now I don't know if the sun is rising or setting. I cannot see. Yes, it means that the sun is either above the horizon, or when you see it, and also it actually has set when we see the sun. So it's an atmospheric trick that we see the sun if it really is not there, because the bottom is raised above the horizon. It look like it's more flattened, the sun, It's by purpose I have chosen to show the complexity of Gauss algorithm computers. We don't have to understand it. I don't understand it, but I can use it.
What do you mean you don't understand that?
It's part of it.
I just give it a quick read and it's so clear to me, Klaus.
Okay, very, very well. I don't understand how Gauss developed that. But the background for that is I wrote an article from 2008 written by a Danish astronomer, and where the title of the article was at sometimes Easter goes wrong. I used computers to calculate the date of Easter, and then the computers told me that Easter Sunday falls on the 21st of April. But the interesting thing was that the result of this calculation is it goes contrary to the Thunberg rule. Easter Day is the Sunday after the first full moon after the vernal equinox, because according to the rule of thumbs, Easter Sunday in 2019 should be Sunday the 24th of March, even if vernal equinox is the 21st of March, which was not. Mm-hmm. So I investigated the problem and found that sometimes the computers goes wrong. it is every 19 years. When you first have a mistake, you go 19 years ahead, and then computers make it wrong when you have Easter. The problem is number 19, which is the Mentorian lunar cycle, is not precise. The Mentorian of the Greek mathematician, he calculated that the moon will still have the same phases, even if it is full or half or a new moon. When the date is the 1st of April, for example, then 19 years after, the moon will rises the same date in the same phase. But this cycle can only last for, I think it's 76 years. Then you have then the moon changes to a new cycle. Mm-hmm. I have investigating these cycles for about 8,000 years, back in time and forward in time. And then I have not made my article about this, but I called it lunar azimuth cycles. And it repeats, I think there is 36 lunar azimuth cycles. And they are working over a period, I think, about 15,000 years. First, I thought it had something to do with the precision of Earth, but no, it's not. But I don't understand it completely. But I know that you can follow a Mentonian cycle for many years. Sometimes there's not when one cycle stops after 76 years. You can find it again after 27 years, and then it continues. But in a period of 400 years, it changed date. So the 1st April will change to the 2nd of April. And it has to go all the dates in the solar year through. So it means in principle, you can have 365 or 26 cycles going in the same way. But I think it's combined to the eclipse cycles, the Saros, which are connected to the sun. But I have to understand how it's connected. I think it's some geometrical idea. No. Okay. Yes. Question?
Comment? Yeah, I do. Comment on this. One of my previous interviews, I don't recall who it was, but the archaeoastronomer said that the apparent position of the moon today is the same as the apparent position of the moon about 3000 BC, accounting with all of these things you just said. And that's the reason we go to, say, the Callanish stones in Skye in the west of Scotland. And today, the alignments with the moon are exact, but perhaps 250 years ago they weren't. Is that what you mean? That there are large cycles that would bring the stones that were built 1000 BC, they would be in alignment, but then they would swing out for another 3,000 years. Is that what you're indicating?
Yes, but in Neolithic times, they will not discover that, because when one lunar azimuth cycle, as I call it, it stops, it will be taken over by another one very close to the date. And this is difficult to explain. One azimuth cycle is separated by the next one by 10 or 11 days. Mm. So maybe it will be, there was a little bit will be a little bit unprecise when you place the stone to see the lunar rise in a specific direction. But I think they will never discover that. It's the same moon which are doing that. We don't have different moons. Only definition to understand the moon's movements. Back to this old slide, because in 38, we will have three different possible Easters.
Oh yeah.
That is a astronomical one. That's really confusing or a mystery. Who decides who is the right Easter? Because in 2038, we will have three possible Easters of Sunday Easters, followed by each other. The 21st of March, we will have an astronomical one. It means that even the church have decided 21st of March is a vernal equinox. We have full moon on the same date. According to an old variation of the rule of thumb, it's possible you can have, if the full moon rises after the time for the vernal equinox, you can have Sunday, and Ilsam is also Sunday, the same date. So you have vertical equinox followed by the full moon time, and then the day is Sunday. So the 21st of March in 2038, the astronomical, it's possible to have the astronomical Easter. Then a week later, you still follow the thumb of rule, and the church, the 28th of March will be Easter, and then in April, the 25th of April, you will have a determined church or Gauss Easter. So my question is, who decides which of these possible Easters is the right Easter? Yeah, you have an answer.
Well, I do. It's going to be the same as always. The Pope is going to choose the 21st. No, the Pope's going to choose the 28th. Walter, at his work, is going to choose the 21st, the astronomical, and everybody else isn't just going to follow along. But I suppose the true date's the 25th, isn't it?
Yes,
because it's both.
it is.
Yeah, it is.
You can find a lot of online calculation programs which calculate Easter in ahead, and they all chooses the 25th of April because it's based on Gauss.
Ah.
But some of the online programs, they calculate wrong.
Mm-hmm.
I found some. Yeah. So I think it's really confusing. But okay, but I don't know who chooses the right one, except they must know about Gauss's algorithm. I've been writing to the Ministry of Church Ministry in Denmark. I've been writing to some cardinals and also to the Pope. But I only got a letter from the Minister of Church in Denmark, and they didn't know what to do with this knowledge because they don't have influence on the date of Easter. Yeah, it's me who are tumbling.
What did you write on? How did you address the letter to the Pope? Did you write the Pope, or did you call him by his name?
No, through the Pope. Yeah, I think it was on what do you call it? what they call the Medi X. There was a Pope thing you can write to,
Oh, yeah.
but I never got an answer.
No, he doesn't.
Yeah, I don't know. No, so I got no answer, and in Denmark also it was a big discussion in 2019 because I launched the idea maybe to change how to determine Easter placement of Easter Sunday. There was a lot of discussion in TV and radio, but the only person, the journalist or scientist, never asked, it was me. I was never. And then there was TV, radio station say, "Okay, Claus, you must come and tell how it is fine." I got half an hour to explain. But in the television, I saw there was an astronomer. He said, it is always vernal equinox, the 21st of March. That's it. But I never got the chance to explain me and why maybe he was not right. And I never saw him since.
On that note, so say a church said, okay, from now on, it's going to be the 21st of March every year. Now, that's going to start to slip, isn't it? Very soon that's going to slip on the actual observable cycles of the sun. But Claus, is that going to slip past some years and then slip back into place? Or will it continually go out so eventually they'll be celebrating Easter on the winter solstice?
I think that it will continue to change because we have been. That's why in history that there was changed the calendar to catch up with the 21st of March. But I don't know how many days, or maybe it will go back again. I never adjust this. I have not done the calculations.
If you look at the lunisolar calendar, you have to make that adjustment for the difference between the sun and the moon, or else it's going to go infinitely out of sync. You have to pull it back. But it would be interesting to know if the Easter or if the vernal equinox would self-correct and then go out and then come back, if it would average the 21st or not. I think I'm getting at.
Okay, this matter I'm not investigating in detail, but if you follow the precision, you know that the star pictures will change from the zodiac. They will move. And so I think that the period which are connected to the zodiac, they will change dates. Mm-hmm. So I don't know exactly what will happen to the vernal equinox or the autumnal equinox, but maybe I can look through it in the next couple of days.
Yeah, I would love to know.
Maybe to hear up because yeah. In few centuries, there will be a couple of days between the determined church, the vernal equinox and the real equinox, the astronomical one.
Hey, Ash, maybe that was understood with the Muisca since you say that they celebrate for a week or 2 weeks.
Yeah, I think so. That we made sure they caught it.
Yeah, maybe they got that. Yeah. Maybe they just included a buffer because we're not sure. We know what's around this time.
So on that note, so the Muiscas were prolific archaeoastronomers, Claus, in ancient Colombia, and it's one of the things there is this standing stone setting, and the stones are in 2 rows of 56 stones, and on the equinox, the stones are aligned within a day or 2 of the equinox, but it's absolutely known the Muiscas celebrated the summer and the winter solstice. No question they had their main festivals on those days. But nobody knows if they might not have even identified an equinox. They might have identified a time which was halfway between the 2 solstices. the equinox might have just passed. Even though they aligned El Infernito, the stones, to the equinox, it might not have been to what we're discussing. It might have just been to a marker on the horizon which indicated the halfway between the two solstices. So I'm reluctant to say the Muiscas worshipped or revered the actual equinox because there's no recorded equinox festivals. There are solstice festivals, but not equinox. So it's difficult to know if they were even actually marking equinox or if they were marking just a halfway moment between the two key solstices. But you're right, Walter, at the solstices, especially down on the island of the sun in Peru, Professor Brian Bauer explained that there was 2 pillars set up in the northwest, an enormous plaza for all of the nobles, the Incas, would have been present. And as the sun set on the solstice, it went down between these 2 pillars. And while there are cardinally aligned buildings east to west, that's not good enough to say there was equinox festivals. They might just have observed the time, which was halfway between the 2 solstice festivals. And for those 2 festivals, they celebrated them for a week, but 3 days before and 3 days after. So they were catching the week of the solstice, rather than us going, today is the solstice. For them, it's more the time of the solstice, yeah?
Right.
Looser.
We want precision. You know, we have all this technology and we base everything off of precision and accuracy. Well, until you have all of these variables well defined, well understood, and understand their relationships, we're going to be in the same boat we're in right now.
Walter himself in 2019 discovered a three-stepped platform, an enormous archaeoastronomically aligned ritual platform on a mountain just virtually across the valley. And we spent time, we found from that platform there were 3 really large field mounds over 2 kilometers. And we aligned it up, Walter. Remember this? And I said, okay, so we drew the line to the equinox. And we found that those platforms were about half a degree off the equinox. We wrote it off and said that is not an intentional alignment. It's half a degree off. We're a pair of idiots. I mean, of course it was an intentional alignment, and it was half a degree off, but that half a degree wouldn't have been regarded as an error back then. It just means this mound was slightly to the right of what would have been the ideal line. So our thirst for accuracy can sometimes be our biggest failing, especially with all these variables that are involved here. I mean, refraction can throw an alignment by 2 degrees. So for us to then look for to negate stuff out with half a degree of error, that's a mistake. We're missing archaeology doing that.
Define another way to determine equinox. It's not my idea, but an astronomer from Portugal, he defined what we call the megalithic equinox. It could be an alternative to how we decide what to be a vernal equinox today. It's a definition which include both sun and the full moon. And as you see on the picture, it need a point in the horizon where you can see actually what is the rising point of the sun in the morning and the rising point of the moon in the evening. This is a tower on a Danish island called Amager, and the town where you have is a watchtower. But you see, this day, the sun rises in autumn at the right side of the tower, and the moon rises at the evening at the left side of the tower. Mm-hmm. It means that this rising point of the sun and the moon has switched over. This is less than 1 degree. So you have to have a marker in a landmarker which can pinpoint the actual direction. And the idea is that this phenomenon has a period of 42 days instead of that the Easter full moon has a period of 35 days. The 35 days is an artificial period because it's cut off in the beginning by the by the 21st of March and in the end of the 25th of April. But in fact, it's the same moon we are talking about, the same moon risings. But the church Easter full moon is artificial shortened off in the beginning or cut off or in the beginning at the end. It's very easy to calculate this time. It's the first time moon and sun cross over in the beginning of year, and the first time in the end of the year where you have the same phenomenon. It can also happen at some other time, but it's the first in spring and the first in autumn. That's what I think the Neolithic people did, because the direction towards the switching point at the horizon is exactly 100 degrees in Denmark in azimuth, calculated from geographical north. And the interesting idea or thing with this direction is almost the same from Africa, North Africa, to the up to the middle of Sweden. So, and nobody could explain that direction because most of the megalithic monuments in Western Europe has this direction. It's about 100 degrees, yes. In Denmark, it's 99 degrees, I think, the mean value. But nobody could think about an astronomical direction which was the same from latitude to latitude. But this phenomenon has this, quality, as you could say, because it's not a point in the landscape, and it's not only pointing towards the moon. It's simply the crossing point at the rising, also at the setting. Because I was very surprised when I one morning saw this phenomenon, and then I saw the moon at my back. It was setting while the sun was rising. There's an explanation for that. And just, in the evening, it was a complete opposite. The moon was rising and the sun was setting behind me. It does not happen the same time, but it's about 12 hours between the sun rises and the moon rises. You need a landmark to see the place at the horizon.
And the difference between the sun and the moon on that day is about a degree. Is that what you're saying on the horizon?
Yeah. This day, but it can also be 6 degrees. Because the moon can jump in the horizon from few degrees to up to 12 degrees in one day, or from one day to another day. But the sun is more stable.
Are you saying that they were marking the midway point between the solstices?
Yes. It's what they did. They did a ritual at that time when the sun and the moon crosses over.
Yes.
But it has nothing to do that they were going to see the fields. But then they have the exactly day where they should make the ritual for spring.
There we go. It's a pre-planting festival, crop.
Pre or post. It depends on the date, because it can vary from the beginning, mid-March to the end of April.
It's a lot clearer to me now. So essentially taking the crops and taking even the what they're marking is the completion of the first quarter of an agricultural year. Is that about right?
Yes, you can say that.
Yeah. Which became Easter down the line.
Mm. Yeah.
It's a prototype for Easter, yes. Exactly.
When you presented your thesis, was it argued? Has anybody rebuffed this? Has anybody pointed out any issues with this? Or do you believe that this is the actual system that was used to determine that time of the year in the Neolithic?
Nobody has anything to argue about that.
But
Walter,
they argued again because
that's your job.
they argued because when this phenomenon happens, it's very possible that you can see a lunar eclipse.
Mm-hmm.
And that was a problem. So they, without knowing that, then they have pinpointed the direction where the moon rises, and then we get a lunar eclipse during the night. The argument is that, okay, if you use the Mentonian cycle, you will only see a lunar eclipse every 19 years. But that's not true. You can see as some explanation about Stonehenge, you can pinpoint a lunar eclipse every 8 or 9 years. That's one of the conclusions about Stonehenge. But in the method I developed and the calculation I made about the crossover eclipses, you can have an visible lunar eclipse every 3 or 4 years, which means that the Neolithic people also could observe a lunar eclipse now and then. Then I thought they maybe use that to have a ritual about death. The darkened moon was the gate to heaven or hell. I don't know.
Mm-hmm. Klaus, I've got a proposition for you. Could you do Walter and I a favor? We come to Colombia once a year exploring, and one of the Moiscas that were here were in their entirety, they weren't lunisolar, it was a lunar culture that followed a lunar calendar. My question to you is this: if this occurrence is at 100 degrees in Norway, what is the angle that we would be looking for in Colombia to see if this same knowledge was expressed in archaeoastronomy? Could you work it out?
Yes, but not in my head.
No. Take your time. We're on the 4.5 degrees latitude, so there should be a significant difference from that 100. It should go up to like 140 or down to like 80, yeah? Or 60.
I've made the formula which can calculate that.
Yeah, there's lots of alignments here. Now, for example, what happens is, I know that, forget 100 degrees in yours, but there's a popular alignment here which is 104 degrees. 102, 103 degrees. So archaeoastronomers look at this and they're inclined to say, that's halfway between the solstices, so this is the cross-quarter day. Halfway between the equinox and the solstice, so it's the cross-quarter days. But we might find that these aren't cross-quarter days, that perhaps this system is in here, because they had a lunar temple with 106 astronomer priestesses calculating eclipses. And they had 3 different types of lunar calendar, and I would love to know what this key angle would be, because it might pop out of the alignment of temples, the orientation of stones, yeah?
But I don't think you will find a 104 degrees or 6 degrees, because the azimuth, when you go from the northern of Africa, where it's 96 degrees, I think in Sweden it will be 103 or 4 degrees.
Sure.
So I think it will be less than 100 degrees. But okay, we can be surprised. I will try to. Yes, this is easy for me because I already developed the formula.
It would be wonderful to know that. It would be a great, because if you're thinking this stands up and that megalithic cultures in Europe saw this, I could only imagine that by medieval cultures, 800 AD in Colombia, that this kind of thing must have been observed. And it would be wonderful to see if it appears in monumental landscapes within the arrangement of these territories.
But it only releases eclipses, lunar eclipses, when the moon is close to its inner or southernmost standstill point.
Yeah.
So we have to compile it with that.
Yeah, there's only 7 degrees of difference here between the moon at its lowest declination and the summer solstice, the winter solstice sunrise. They're very close. The southernmost declination of the moon and the annual winter solstice rise, they're very close. They're 7 degrees. So, and also, you know as well, Klaus, the Earth isn't round. It bulges at the equator, so you might find there's very little degree change in the first 10 degrees above the equator, but then there's a remarkable change as you come up into Norway, further up into Scotland. And so I would really love to get that from you, an angle. That would be useful for us, Walter.
I will do that.
Yeah. One thing to add to that, Ashley, a lot of the stuff that we do up where you're at, yes, we look through a lot of atmosphere, and you're going to get that Rayleigh scattering, so you'll have more diffraction if, and only if, in my opinion, if we're looking on top of a mountain down towards the surface. Where you are, you're kind of up in the hills, so the moon and the sun has already traversed all of that space. So you're not going to get as much diffraction. So I don't think that's going to come into as much of a play as it would as if we were, say, here in Nebraska, where our sunsets, in my opinion, are some of the most beautiful because they're so red, because we are looking through so much atmosphere.
Yeah, you're bang on. So these photographs that Klaus has been showing, there's a great distance between the observer and the horizon where that refraction is occurring. Here, where this chief temple of the moon is in Chia, Walter, there's the mountains, the hills behind the building. It means the fixed horizon is actually 1 kilometer in front of you. So when you see the moon going down, you can see how sharp the trees are on the hill.
Right.
There's very little visual refraction. In the Andes, there's no pollution in the air. So it's very, very crisp. I agree with you with there, Walter, compared to a long distance over a desert or, say, a sea.
So while I was hoping that would play into our measurements, because we'd have that little buffer zone of 2-3 degrees, I don't think that's applicable. We got to use the science follow the science where it takes us, not force it into where it doesn't belong.
Yeah, you see that in their solstice alignment. So the summer solstice here, the winter solstice sunrise is 114.5 degrees. The buildings and the towns and the temples that are aligned to that are within 1/4 of a degree of accuracy.
Yeah, but I can change the variables in the formula for refraction and parallaxes and so on. And I can send you the formula also.
What I would love...
Maybe I missed something.
It would be hard for you to generate a degree, like you're looking for 74 degrees, but a bandwidth, between 87 and 89, that kind of thing from you.
Yeah, it is possible. So my question is, who decides which Sunday is the correct Easter Sunday?
Can you answer it?
So that's it here. No?
No.
I will choose the same date, 1st of April, the first Sunday after the 1st of April. But yes, so it's enough for today. I'm sorry I pronounce the words sometimes a little, funny.
Listen, Klaus, I live in.
I
I'm Scottish and I live in Colombia. And every time I hear you mispronounce a word, 5 years ago I would have thought, what's he talking about? Now I'm like, oh my, I so understand what it's like trying to speak another language, you know?
Mm-hmm.
Not easy.
No, but it's only the pronouncing. I understand perfectly what you say, but I will improve next time. And nice to meet you, Walter.
Yes, nice to meet you too. I can't wait to see what you have about the lunar stuff that Ashley mentioned.
We'll organize another recording day, maybe in 3 or 4 weeks' time. We'll get this again and we'll all be better at it. Now we know how this works with sharing screens and everything.
Sure.
Yeah. Okay.
Super, guys. Thanks again. Thank you.